Hello, this is Ms. DB, and in this short video I'm going to show you how to do the second half of the worksheet for Chapter 2, Section 8. This is the part where we are going to solve absolute value inequalities, so the inequalities part. So here's what we do. We isolate the absolute value expression. Sometimes that's already done. We rewrite it as a compound inequality, and we solve each part for x. But I want you to stop here and think and look at what you have once you get to this point, because sometimes there's a shortcut. Alright, so let's see. First we have to make sure we have isolated the absolute value. It means that we only have absolute value on one side. So that's done. So let's think and look at what we have. It says that the absolute value of negative 4q plus 2, so this, of course, it's the absolute value, so it'll be a positive number, is greater than or equal to 10. So that makes sense. We can go ahead and solve this problem. So what we do is we set this equal to two separate statements. The first one, all we do is drop these bars and write the equation, the inequality, just as it would be. So negative 4q plus 2 is greater than or equal to 10. In the second, we reverse the inequality sign, and we change this number to its opposite. So this part stays the same, left side is the same. This sign is reversed, and this is the opposite sign. So the right side gets the opposite sign. Now we solve both of these little inequalities just like you would have earlier. So in this one we would subtract 2, and we'd get negative 4q is greater than or equal to 8. Oh, that part's already there. And then in this one we would subtract 2, and we'd get negative 4q is less than or equal to negative 12. Then we'll divide both sides by negative 4. And in this one we would get q is greater than or equal, oh, it's a negative. When you divide by a negative, don't forget you change that sign. So we're dividing both of these by a negative. Both of those inequality signs will flip. So now we have, this would be q is less than or equal to negative 2, or q is greater than or equal to a positive 3. That's it, really. That's really your answer, except that you have to graph it. So you would put a closed circle at negative 2 and a closed circle at 3. And less than negative 2 means to go this way, and greater than 3 means to go this way. You can also write it in this notation. This is a different way to write it, that we go from negative infinity to negative 2 and 3 to infinity. But you don't have to. You can leave it right here. This can be the way you write your answer, or this way. So there's more than one way to write your answer. And then you can check it by making sure that those points work. Okay, so here's our next one, to another example. So the first step was to make sure that we have just the absolute value on one side by itself. We don't have that yet in this one. I need to add 3 to both sides so that I'll have that. Now I have the absolute value of 0.5r is greater than or equal to 0. Now here's where I want you to stop and think. This says that the absolute value of this side, which will be a positive number, will be greater than or equal to 0. Well, positive numbers are always greater than or equal to 0. The absolute value of any number will be 0 or greater than 0. So let's say you didn't notice that, you forgot to stop and think, and we are going to go ahead and write it in its two different ways. Well, one way is you just drop the absolute value signs, and you would write 0.5r is greater than or equal to 0. The other way is that you reverse this and you take the opposite of that right side. Well, the opposite of 0 is still 0. So we have 0.5r is greater than or equal to 0, or 0.5r is less than or equal to 0. Here's another place where you might stop and say, if I'm looking at this, this seems like pretty much every single number is covered here. So r is less than or equal to 0, or r is greater than or equal to 0. If I graph that, here's 0. I'd have a solid dot at 0 going this way, and a solid dot at 0 going. It's everything. It's all real numbers. Okay, so here's what I could have done. This is the shortcut I was talking about. You still have to do the first step. You still have to isolate the absolute value. Still get this. But here's where I would stop, and I would say, this is a positive number because it's the absolute value of something. It's always going to be 0 or greater than 0. The only way you'd get 0 is at the absolute value of 0. But any negative number, you would take the absolute value of it and get a positive. It's always going to be a true statement, no matter what. It's always true. So you can then say that the solution is all real numbers. You can right now say all real numbers, and that's what you would write. You don't really have to graph all real numbers, but if you did, it would just be the whole number line filled in. So stop, look, and think once you write your absolute value inequality. Okay, in this one, it's already got step 1 done. That I already have the absolute value isolated. It's by itself. It's greater than a positive number, so I can't really make any, it is going to be greater than 12. I can't do any shortcuts here, so I write my 2 different inequalities. The first one, all I do is drop the bars. The second one, I change the greater than to a less than, and I change the 12 to a negative 12. Then you solve both of them, add 8, and then you will divide both of them by 4. We're not dividing by any negatives, so no signs get flipped around. So my answer is x is greater than 5 or x is less than negative 1. Make sure that when you graph this that you remember that negative 1 is over here and 5 is over here. X is less than negative 1 means an open circle at negative 1 and an arrow to the right. X is greater than 5 means an open circle here and an arrow this way. So this would be your answer, both the inequalities and the number line. You can also write it in interval notation like this. That's a nice way to write it. Or you can write in this form that we've looked at before too. Any of those 3 ways of writing it, but you do have to have your number line as well. Okay, another example. This one is not yet isolated the absolute values. The first thing you would have to do is subtract the 36. So now I would have the absolute value of 3x. Now I shouldn't write on here because it's going to do it for me, and I'll just be is greater than negative 24. Now you might want to think and look here, but I'm going to go ahead and pretend that I didn't think and look and just write down what we would have. We would write one of ours with just dropping the absolute value signs, 3x is greater than negative 24. On the other one, you would switch the greater than to a less than, switch negative 24 to positive 24. Solve both sides, divide by 3. You get x is greater than negative 8, or x is less than 8. So here's, oh, they didn't even put 8 on here. I'm going to go back a step. Here's our number line. Here's negative 8. Here's 8. We want the numbers that are greater than negative 8 and the numbers that are less than 8. They're going to go past each other here. The numbers greater than negative 8, or, it's an or, not an and, or less than 8 are going forever in both directions. So the answer would be all real numbers because you would end up filling in the whole number line. Now let's do the look and think method. We would still start the same way. We would subtract 36 from both sides and get the absolute value of 3x is greater than negative 24. Now stop. This is a positive number. When you take the absolute value of 3x, whatever that is, it doesn't matter, you're going to get a positive number. Is a positive number going to be greater than negative 24? Always. It's always true. No matter what x is, whatever value of x you can dream up and put in there, it's always going to be greater than negative 24 once you multiply it by 3 and take the absolute value of it. So you can right then go to the answer of all real numbers. Here's another example. This one looks hard, but really it's not. Our first step is to isolate the absolute value expression, so we would multiply both sides by 3. That cancels the 3 and leaves us with the absolute value of 2x plus 7 is less than or equal to 3. So it's less than a positive number. Yeah, there's different things this could be. I have to keep working. I write my 2 different expressions. 2x plus 7 is less than or equal to 3, and 2x plus 7 is greater than or equal to negative 3. And then I solve both of those. I would remember that we changed this part and this part when we did that. And then I solve both of them by subtracting 7, and then I would divide by 2, which is a positive number, so I don't have to switch my signs. So I get that x is less than or equal to -2. I'm going to put my number line here. There's a little room. And x is greater than or equal to, oh, see right there I made a mistake. It's -5. So I need the -5 farther to the left on the number line, and the -2 would be here. So it's greater than or equal to -5 and less than or equal to -2. Let's look at the next page. And here they graphed it, so it's only those values. And that's done. All right, in this example, we would start by isolating the absolute value by multiplying both sides by a -2. So when we do that, let's see what we have. On this side, we'd have the -6. That makes sense. On this side, we would have -2 times -1/2. The 2's cancel, and we have negative times -1, which is a positive 1. So everything cancels, and we're left with the absolute value of p minus 2 is less than or equal to -6. So we have a positive value being less than or equal to a -6. It doesn't seem logical. So I'm going to write it down. P minus 2 is less than or equal to -6. And then the other one is the same thing, except I change this. They don't need these signs. That's a typo. And the other one, I would change this to a greater than, and I would change the -6 to a +6. So you change two things on the second. And then I solve this by adding 2 to both sides. Same with this one. So I would have p is less than or equal to -4, and p is greater than or equal to 8. And here we would stop and we would graph it. And we'd say, okay, p is less than or equal to -4, and p is greater than or equal to 8. But it's an and. It has to be both of them. What number is over here and over here? There is no numbers that are in both of those areas. There's no solution that works to make it be less than -4 and also greater than 8. It's not possible. So you would say no solution, or the empty set if you want. So here's the same problem, and I'm going to show you where you would stop and look at what you got. So first, again, you have to isolate the absolute value, so you multiply by -2. And then you stop here and you say, wait a minute, so this means that I have a positive number less than a negative number. When is a positive number going to be less than a negative number? It's never going to happen. If you ever get the absolute value less than or equal to a negative number, whatever that is, there's no solution. It's not a possible thing. If you ever get the absolute value that is greater than or equal to a negative number, or if you get the absolute value is greater than or equal to 0, this could just be greater than 2, by the way, then you would have all real numbers as a solution. So if you stop and think and look at what you have, you can get to these no solutions or all real numbers, if that's an answer, quicker. And that's what I wanted to go over today. Thank you very much and have a great day.